By the year 2054, the global population is projected to hit 9.796 billion people.
Which is just a massive number.
It's staggering. Honestly, it's a terrifying projection, and that comes directly from the United Nations.
Yeah, it's not just a guess.
Right. And I want you, the listener, to just pause and actually try to visualize that number for a second. Think about your own morning commute.
Oh yeah, the traffic.
Exactly. The traffic lights, the crowded buses, the subway platforms. Picture your city's waste management system, like the garbage trucks doing their daily rounds.
It's just the physical space that takes up.
Right, and think about your local power grid straining during, say, a summer heat wave.
We've all seen the brownouts.
Yeah. Now, imagine those exact same physical, currently overstressed systems trying to handle explosive, exponential population growth. Because the vast, vast majority of those nearly 10 billion human beings are going to be crammed into urban areas.
And that right there, I mean, it creates a diagnostic nightmare for urban planners. We are looking at a future where we simply cannot just, pour more concrete.
We're out of room.
Exactly. We can't just add 10 more lanes to a highway or carve out entirely new sanitation grids in cities that are already physically maxed out. The geographic footprint of our modern urban centers has strict limits.
So what's the alternative?
Well, so the only viable path forward to prevent these cities from collapsing under their own weight is radical, unprecedented efficiency. We are basically being forced to do significantly more with the exact same amount of physical space.
Which brings us directly to the mission of today's deep dive. We are looking at a comprehensive, newly updated 2026 systematic mapping study by Brazilian researchers.
Right. Bruno B. Boniati and Rafael Z. Franz.
Yes, Boniati and friends. And I need to stress right up front, this is not a dry academic paper about abstract technology.
Not at all.
This is quite literally a blueprint for survival. We're looking at how a massive, incredibly diverse country of continental proportions, Brazil in this case, has spent 12 years obsessively trying to engineer the cities of the future.
12 years, yeah, from 2014 to 2025.
Using information and communication technologies, or ICTs.
It really is a fascinating longitudinal look at a country trying to solve real-time escalating crises. Because these researchers and engineers, they aren't theorizing in a vacuum.
Right, they're on the ground.
Yeah, they are applying digital solutions to physical urban decay, rapid expansion, resource scarcity, and, extreme regional inequality.
Okay, let's unpack this, because before we look at the specific data, the 702 articles they analyzed, the algorithms, the sensor networks, we really have to establish a baseline.
We definitely need to define our terms here.
Right, we need to agree on what the term smart city actually means. Because if you look at the current cultural zeitgeist, or just listen to municipal marketing pitches, the term is vastly misunderstood.
Oh, completely. It's become a buzzword.
Yeah. I think a lot of people hear smart city, and they imagine some sleek, neon-lit sci-fi metropolis with flying cars. Or, on the flip side, they think it just means installing Wi-Fi routers on public park benches.
And it's so much more foundational than that. The definition is really the anchor of this entire study, and it's where Boniati and France really plant their flag.
So how do they define it?
Let's start with the functional baseline. A smart city is an urban space that uses information and communication technologies to continuously monitor the status of its critical infrastructure.
Okay, so constantly checking its own pulse.
Basically, yeah. It absorbs massive amounts of data to optimize resource utilization, strategically plan infrastructure maintenance, and ultimately improve the quality of life and the efficiency of the services delivered to its citizens.
So the equation is basically constant data ingestion leads to optimized living.
That's the theory, anyway.
It sounds flawless on paper, but I feel like there's a trap there. It feels like an engineering solution to a human problem, and humans aren't, predictable algorithms.
That is the pivotal tension of the whole paper. The researchers explicitly invoke an analytical framework called socio-technical theory to address that exact trap.
Socio-technical theory. Okay, what is that?
It was formulated by thinkers like Sawyer and Jarahi. And socio-technical theory basically argues that the performance, the actual societal value of any system comes from the joint, simultaneous optimization of its technical subsystems and its social subsystems.
Meaning you can't just slap a microchip on a municipal trash can, declare the city smart, and walk away.
Exactly.
The technology has to interact constructively with the people who are actually throwing away the garbage.
That's exactly the point the authors make by citing researchers Bria and Morozov. They make this vital, highly cautionary distinction. A city completely blanketed in sensors, cameras, and data harvesting algorithms is not automatically a smart city.
Right, it could just be a spy operation.
Yes, precisely. If that technical layer exists without a robust social framework, without governance, transparency, and citizen agency, it degrades into a surveillance trap.
A surveillance trap, wow.
It ceases to be an environment optimized for living, and it becomes a space designed for continuous data extraction and behavioral modulation.
I look at it like the difference between buying a smartphone that actually helps you organize your life. You know, it holds your calendar, it runs your banking app, it gives you navigation.
Actually, good stuff, yeah.
Right. Versus a smartphone that comes preloaded with undeletable bloatware that just silently tracks your physical movements so some third party can sell your location data to advertisers.
That is a perfect analogy.
Because the physical hardware is identical.
Right.
Both phones have a GPS, both have a processor, both have a battery. But one is a tool that serves you, and the other treats you as the raw material to be harvested.
The intent and the power dynamic are what change, and that bloatware analogy captures the surveillance trap perfectly. The technical components of a smart city, the IoT sensors, the 5G networks are agnostic.
They don't have a moral compass.
Right. They don't care if they are optimizing a bus route or tracking a political dissident.
So how does a city avoid becoming that dystopian, bloatware-loaded environment? I mean, if the hardware is neutral, how do we guarantee the helpful version of the smart city?
Well, according to the socio-technical philosophy driving this Brazilian research, true intelligence in a city requires technological sovereignty and meaningful citizen participation.
Meaning the people have the power.
Yes. The implementation of the tech must be fundamentally rooted in social inclusion, transparent governance, and justice. The system has to be explicitly designed from the ground up to serve the citizen, rather than merely monitoring them.
So it's not a top-down mandate.
No, the people living in the city must have a tangible say in how the technology is deployed, what data is collected, and who controls the benefits derived from that data. If those social dimensions are ignored, the technical optimization ultimately fails the society it was built for.
With that really profound baseline established, this idea that technology must bend to the human, not the other way around, how does a country actually begin building toward that ideal?
It takes a spark, usually.
Right, and I want to look at the historical timeline of this research, because when I looked at the data in this study, the sheer acceleration of the research output caught me totally off guard.
The spike in publications is wild.
It is. The authors found 702 strictly verified articles published over a 12-year period. But prior to 2014, there was practically nothing.
Barely a blip on the radar.
I think the study notes only 6 published works existed before 2014. Then suddenly, just an absolute explosion of data. What flipped the switch?
Well, technology requires a catalyst. Funding, academic focus, and governmental green lights don't just, spontaneously generate out of thin air.
Sure, you need a reason to spend the money.
Exactly. And for Brazil, the catalyst was the pressure cooker of hosting 2 consecutive global mega events. You had the 2014 FIFA World Cup, followed almost immediately by the 2016 Olympic Games in Rio de Janeiro.
Oh, man. That is a staggering amount of logistical pressure.
It's unprecedented for a developing
So
nation.
you have a developing nation suddenly on the hook to host the entire planet. Millions of tourists, thousands of athletes, global media syndicates, all descending on cities that, in many cases, were already deeply struggling to support their own baseline populations.
Right. It operated as a massive, unavoidable forcing function for urban overhaul across 12 major capitals. And you can't solve that by just embarking on decade-long construction projects.
No, you don't have the time.
Exactly. You can't build a completely new functioning subway line in 6 months. The only alternative is to make the existing infrastructure, the buses, the trains, the traffic grids, the emergency services run exponentially smarter.
Desperation breeds innovation, as they say.
It really does. What's fascinating here is we see a massive spike in research, particularly around urban mobility and crowd management, during this specific window.
That makes total sense.
But if we dig into the types of publications being produced, the data reveals the maturation of the field. Between 2014 and 2018, there is a very steep increase in total publications, but the vast majority of these early works were conference papers.
I want to pause on that distinction, actually, because not all academic publishing is created equal. A conference paper is generally an entirely different beast than a peer-reviewed journal article, right?
Oh, absolutely.
It's a much faster timeline.
Much faster. Conference papers are generally the front line of academic brainstorming. They are exploratory.
Like pitching an idea.
Right. A researcher might say, hey, I have this theoretical model for an ultrasonic sensor network at a soccer stadium. Here is a preliminary small-scale test. It's about fast-paced idea sharing and getting immediate feedback from peers in the room.
It's kind of the Wild West of prototyping.
Yeah, that's a good way to put it.
But then the data shows that around 2019, the sheer volume of output stabilizes and the nature of the research shifts heavily. From 2019 through 2025, there is a massive migration into peer-reviewed journals.
The quality goes way up.
By the end of the 12 years, journal articles make up 45.2% of the entire output.
That shift from rapid-fire conference presentations to rigorous journal publications is the absolute hallmark of a scientific field maturing.
Because it's harder to get into a journal.
Way harder.
Oh.
To get published in a top-tier journal, your research has to survive a brutal peer review process. It requires longer testing phases, verifiable real-world data, and proving methodologies.
You can't just have a cool theory anymore.
Exactly. That 45.2% figure proves that the Brazilian ICT research community successfully moved out of the theoretical what-if phase triggered by the World Cup and evolved into producing hardened, tested science. The idea survived contact with reality.
And it seems like it wasn't just a grassroots academic movement by the end of that decade either. The government started realizing that what began as a frantic scramble to manage Olympic tourists was actually the only viable long-term management strategy for the country.
The study specifically highlights this top-down endorsement. You see the 2020 Brazilian Letter for Smart Cities issued by the executive branch.
Wow, so the very top.
Yeah, and then a major 2021 strategic study commissioned by the Chamber of Deputies. The federal government stepped in to structurally organize, fund, and endorse the ecosystem. They realized smart cities weren't a luxury anymore.
They were infrastructural necessities.
Complete.
So we know the timeline. We know the 2014 World Cup lit the match, and by 2025, it's a formalized, state-backed scientific powerhouse. But Brazil is the fifth largest country in the world by area.
It's massive.
It is wildly diverse in its climate, its economy, and its demographics. So when we look at the geographic map of where this research is actually being conducted, it reveals a fascinating narrative about localized problem solving. This isn't monolith.
Not at all. The regional disparities are incredibly stark, and they paint a vivid picture of the country's academic concentration. The southeast region of Brazil absolutely dominates this mapping study.
Producing what, like over half?
Yeah, producing 58% of all the research.
Yeah.
That's followed by the northeast region at 44% and the south at 29%. Meanwhile, the central west and north regions account for only 7% and 5% respectively.
And within those high-producing regions, you have these absolute heavyweight academic institutions pulling the cart. You have the Federal University of Rio Grande do Norte, or UFRN, in the Northeast, involved in 11% of all studies.
Right, they are a huge player.
Then in the Southeast, you have UNICAMP at 9% and the University of São Paulo at 8%.
But you know, the truly critical insight isn't just about who is publishing the highest volume of papers. It's about what specific problems they are applying their ICT research toward.
Because the problems aren't the same everywhere.
Exactly. Because a researcher in São Paulo wakes up to a fundamentally different existential urban threat than a researcher in the Amazon basin or the state of Bahia.
This might be the most revealing part of the entire deep dive, honestly, because it grounds all this high-level tech in practical, localized reality.
It makes it real.
Yeah. If we look at the South and Southeast regions, institutions like UNICAMP and UTFPR, their research is almost pathologically obsessed with transportation and urban mobility.
Which makes perfect sense when you look at the map.
Right. These regions contain massive metropolitan areas like São Paulo and Rio de Janeiro. They contain the largest vehicle fleets in the entire country. Their absolute primary threat is gridlock.
Just an absolute freezing of movement that paralyzes the economy.
So naturally, their smart city solutions are heavily biased toward dynamic traffic algorithms, real-time routing, and optimizing public transit networks.
Then you shift the lens to the Northeast region, specifically looking at institutions in the state of Bahia, and their research profile completely flips.
They aren't looking at traffic.
They aren't primarily focused on traffic algorithms, no. They are intensely focused on public safety and security scenarios.
Which is a direct, sobering reflection of their socioeconomic environment. The study cites data from the Brazilian Forum of Public Security, noting that Bahia has the second highest rate of intentional mortality in Brazil.
It's a very different daily reality.
If you are an engineer or an urban planner living in that reality, optimizing a bus schedule is a secondary concern to keeping citizens physically safe from violence.
Exactly. So their smart city research pivots toward predictive policing algorithms, gunshot detection networks, and optimizing emergency response times.
And if you move to the north region, which encompasses the Amazon rainforest, you are dealing with a massive geographical area with an incredibly low population density.
Right. Totally different again.
The urban threats there are entirely different. Their research is overwhelmingly focused on fundamental telecommunications infrastructure. Because, I mean, you cannot implement a smart traffic light or a gunshot detection network if you don't have a reliable data signal.
I love how this dismantles the idea that technology exists in a vacuum. You don't just build a highly sophisticated AI-driven digital twin of a city. If your most pressing daily problem is getting a basic cell phone signal across a sprawling, low-density landscape.
The harsh reality of the physical environment dictates the engineering.
The socio-technical reality on the ground drives the hardware and the software. It's also crucial to highlight the actual architects behind this engineering. The study identifies the top minds driving this domestic network forward.
The heavy hitters.
Yes. Jules Jose Puga Coelho Rodriguez and Victor Hugo Casa de Albuquerque. And these aren't just prolific writers within this specific niche.
No, they are huge names.
According to a 2024 ranking cited in the study, they are the #1 and #2 computer scientists in all of Brazil. Between the two of them, they co-authored 3 of the 4 most cited papers in this entire 12-year mapping study.
That is wild. They're practically writing the rule book themselves.
We also have to look at the institutional hubs acting as force multipliers for these minds. The Digital Metropolis Institute, or IMD, located at UFRN in the city of Nokal, is a massive engine for this work.
A huge hub.
Half of the top 10 individual researchers identified in this mapping study are affiliated with that single institute. They have essentially turned the city of Natal into a living laboratory for digital transformation.
So Brazil is building this incredibly robust internal network-localized hubs in the northeast, the south, the southeast, all attacking their specific regional problems.
But science is rarely a solitary pursuit on a national level.
Right. When we look at who Brazil is calling for help, who they are collaborating with internationally, the data reveals a massive web, but also a glaring, frankly bizarre blind spot.
The international network is expansive, for sure. Brazilian institutions are co-publishing with researchers from 53 distinct countries.
That's a lot of countries.
It is. The top partners are somewhat expected given historical and academic ties. Portugal is the undisputed #1 partner with 68 joint publications.
Makes sense. You have the shared language, the deep historical roots.
Exactly. Then you have the United States with 35 publications, Italy with 27, Canada with 24, and Spain with 22.
So the European and North American connections are incredibly strong. But when you look at the global map of this collaboration, something is missing. It's almost shocking.
It really stands out in the data.
Brazilian researchers have virtually zero collaboration with the rest of South America and absolutely zero collaboration with the continent of Africa. Aside from a microscopic handful of papers with Peru, Chile, and Ecuador, Brazil is operating like an isolated research island on its own continent.
And the authors of the study point this out as a major deficiency and a critical area for future growth. The lack of South-South collaboration is a profound geopolitical blind spot.
I struggle to understand the logic there. Why would an urban planner in São Paulo default to collaborating with a researcher in Germany or Canada to solve a tropical, developing world urban crisis?
It seems counterintuitive.
Wouldn't it make infinitely more sense to pick up the phone and call an engineer in Bogota or Buenos Aires or Lagos? Those cities face the exact same chaotic socioeconomic hurdles, the same climate challenges, the same informal economies, and the same municipal budgetary constraints.
It comes down to the structural realities of global academia. Funding, prestige, and high-impact journals are overwhelmingly concentrated in the global north.
Follow the money.
Right. Researchers are incentivized to partner with well-funded European or American universities to secure grants and achieve international visibility. But the consequence of this, as you pointed out, is the danger of mismatch.
What do you mean by mismatch?
Well, if Brazil relies solely on the global north, it risks importing smart city solutions engineered for wealthy, highly structured, predictable European cities.
Right. A dynamic traffic algorithm designed for the orderly streets of Munich might completely fail when applied to the organic, informal, highly dynamic traffic flow of a Brazilian favela.
They're completely different environments.
They need solutions engineered for the specific realities of the global south, which makes the lack of collaboration with their continental neighbors a massive missed opportunity.
It's a vital area for future socio-technical alignment. The technology must fit the society it serves, not the other way around.
The geography and the geopolitics are fascinating, but I want to get my hands dirty here. We know why they are researching, where they are, and who they're working with. But what is the actual hardware and software running on the streets of these cities right now? What are the scenarios and the tech?
To organize this massive volume of technology, the researchers applied a global standard known as the ABNT NBR ISO 37122.
Wow, okay. That is a dense acronym. Why does a global standard matter in this context? Why not just let every city define what makes it smart?
Because without a strict standard, you get smart washing.
Smart washing, like greenwashing, but for tech.
Exactly. Every mayor in the world wants to claim they run a smart city because they, I don't know, installed a touchscreen kiosk at the local library. The ISO 37122 standard prevents that. It is a rigorous, globally recognized framework that uses 80 specific indicators across 19 dimensions.
What kind of dimensions?
It covers everything from energy consumption and water management to governance and public recreation. It provides an actual, verifiable scorecard.
It holds the engineering accountable. So when the researchers mapped the 702 Brazilian studies onto these 19 dimensions, what did the scorecard look like?
They found that about a third of the studies, 33.2%, are cross-cutting. This means the technology acts as a foundational layer applicable to multiple areas at once, like an overarching cloud infrastructure or a municipal Wi-Fi grid.
Stuff everyone uses.
Right. But when looking at specific targeted dimensions, transportation is the undisputed focus, accounting for 21.2% of the studies. Governance and safety follow, tied at 9.7% each.
And from a purely technological perspective, what is the core tool driving all of this? Data management. It is the dominant theme across 17.3% of all studies. The sheer ability to collect, clean, categorize, store, and route data is the bedrock of everything else.
You can't do anything without the data.
Exactly. You cannot have AI, you cannot have dynamic routing without pristine data management. The most frequent intersections in the study are artificial intelligence applied to transport and data management applied to transport.
I want to spend some serious time walking through these specific, highly cited solutions mentioned in the paper, because this is where the science fiction becomes reality.
It gets really cool here.
Let's start with ubiquitous computing and something called CDRs. There's a highly cited paper by Barbosa et al. That explores this. Now, I know my phone tracks me, but what exactly is a CDR, and how does a city use it to fix public transit?
CDR stands for Call Details Record. Every single time your smartphone interacts with the cell tower, whether you are making a call, sending a text, or even if the phone is just sitting in your pocket silently pinging the network to say, I'm still here, the telecommunications company generates a CDR.
So it's leaving a breadcrumb trail.
Right. It creates a massive, continuous, real-time data set of where millions of devices are located and how fast they are moving through physical space.
By triangulating the signal between the towers.
Yeah.
So basically, your phone connecting to a cell tower is essentially casting a silent vote for a new bus route.
In a sense, yes. The Barbosa paper investigates how municipal control centers can ingest this anonymized CDR data from the telecom companies to completely redesign public transport grids.
Because the old way is just guessing.
Yeah, historically, a city would have to send out surveyors with clipboards or rely on outdated census data to guess where people were commuting from and where they needed to go.
Which takes forever and is usually wrong by the time they finish.
Exactly. With CDRs, the city can literally watch the macro flow of human movement in real time. If the data shows 10,000 phones moving from a specific residential suburb to a downtown commercial sector every morning at 7 a.m., but there is no direct train line or express bus serving that route.
The data tells them exactly where the gap is.
The data tells the planners exactly where the infrastructure is failing and where to allocate resources.
It's brilliant, but it immediately triggers the socio-technical alarm bells we talked about earlier, the surveillance trap. How is a city tracking the real-time movement of millions of individual phones, not a terrifying dystopian nightmare?
And that is exactly the core challenge Barbosa and other researchers highlight. The capability of the technology is incredible, but it is deeply perilous.
It's a double-edged sword.
It absolutely requires airtight data privacy laws, rigorous anonymization techniques, where the data points are stripped of any identifying personal information, and transparent governance.
So the city knows a phone moved from point A to point B, but they don't know it was my phone.
That's the goal. If the governance fails, or if a bad actor gains access, it is a surveillance state. If the governance succeeds and the data is truly anonymized, you get the most efficient, responsive public transit system possible.
The stakes are incredibly high. Let's look at another major technological pillar discussed in the paper: digital twins and fog computing. The mappings by Almeida and Silva explore these heavily. Now, I hear the term the cloud constantly, but what is fog computing?
To understand the fog, you really have to understand the limitations of the cloud. The computing cloud is essentially a massive centralized server farm, often located hundreds or thousands of miles away from the city using it.
It's physical hardware somewhere else.
Right. If a smart traffic light in Rio de Janeiro detects a car crash, and it has to send that heavy video feed all the way to a cloud server in Virginia to be processed by an AI, and then wait for the instruction to turn the intersection lights red.
That round-trip data journey takes time.
We call that latency. And if we are talking about a car crash or an emergency response, those milliseconds of latency can be lethal.
Right, you can't be waiting for a server in Virginia to tell an ambulance to go.
Exactly. So fog computing is a localized architectural shift. Instead of sending every piece of data to a distant centralized authority, you bring the processing power closer to the ground, closer to the edge of the network.
Down into the fog?
Yes. You place mini servers on street corners, inside the cell towers, or built directly into the traffic lights themselves. It's decentralized.
I see. So if the cloud is the corporate headquarters on the other side of the country, the fog is the manager on the factory floor.
That is a superb analogy.
If the assembly line jams, the floor manager doesn't need to call the CEO to ask permission to hit the stop button.
Yeah.
They have the localized authority and processing power to make a split-second decision.
Spot on. The data is processed locally in the fog, allowing the smart city to react to physical emergencies in true, latency-free, real time.
And how do digital twins fit into this architecture?
A digital twin is exactly what it sounds like. It is a highly complex one-to-one virtual simulation of the physical city. By pulling in the massive streams of data from the fog nodes and the cloud servers, urban planners can create a virtual model of their city that acts identically to the real one.
Like a digital clone.
Yes. Before a city council decides to close a major bridge for 6 months of repairs, they don't have to guess the impact. They can close the bridge in the digital twin, run a simulation based on real historical traffic data, and watch exactly how the congestion will spill over into surrounding neighborhoods.
That is wild. They can test things without breaking the real city.
They can optimize the detours virtually before moving a single physical traffic cone.
It's like playing SimCity, but the consequences are real. I want to shift gears from transportation to healthcare, because there is a highly cited paper by Vora et al. Regarding the use of blockchain in smart cities.
This is a really important pivot.
I hear the word blockchain and I immediately think of, someone in their basement trading cryptocurrency. But Vora's paper proposes a framework called BHEME, applying blockchain to hospital records. I'm assuming this is because a distributed ledger removes the single point of failure that a centralized hospital server usually has.
You've hit the nail on the head. The application here has nothing to do with financial speculation. The problem in modern healthcare is that electronic health records, your EHRs, are incredibly sensitive.
And highly targeted by malicious actors.
Oh, massively targeted. Yet they need to be shared across a complex network of different primary care doctors, specialists, hospitals, and pharmacies seamlessly. If all that data sits in a single centralized hospital database, it is a massive, lucrative target for a hacker.
Right, because if they breach that one server, they get the medical history, the social security numbers, and the insurance data of millions of people in one fell swoop.
It's a goldmine. So the BHEME framework proposes using a blockchain, a decentralized, cryptographically secured, immutable ledger. It allows a patient's medical history to be updated and shared across the entire smart city's medical infrastructure without relying on a single, vulnerable central server.
Because everyone holds a piece of the puzzle.
Because the ledger is distributed, altering or hacking the data becomes computationally nearly impossible. It grants the patient ultimate sovereignty over their data, while ensuring that any authorized doctor they visit in the city has instant, verified, untampered access to their medical history.
Speaking of hackers, as these cities get smarter, their attacks surface. The number of ways a bad actor can infiltrate the system gets exponentially larger.
It's a constant arms race.
The paper highlights research by Cervantes et al. About preventing something called sinkhole attacks in IoT routing. Sinkhole attack sounds ominous. What exactly is happening there?
In an Internet of Things, or IoT, network imagine thousands of small, low-power environmental sensors spread across a city measuring air quality.
Okay, I'm picturing them.
Those sensors don't all connect directly to the main server. They pass data to each other, hopping from node to node like a bucket brigade, finding the most efficient route back to the control center.
To save power.
Right. In a sinkhole attack, a hacker compromises just one of those sensor nodes and fundamentally alters its routing protocol. The compromised node broadcasts a lie to all the surrounding sensors.
What kind of lie?
It says, hey, I have the absolute fastest, shortest route back to the control center. Route all your data through me.
Oh, wow. It acts like a gravitational pull, a black hole for the data.
Yes. All the surrounding uncompromised sensors believe the lie and route their critical data into this single compromised node, and the node simply drops it. It deletes the data instead of passing it along.
So it's not even stealing it, it's just destroying the network's vision.
The control center is suddenly blinded to an entire sector of the city because all the data from that area is falling into the sinkhole. Cervantes and his team designed specialized intrusion detection systems specifically for these low-power IoT networks.
How do they fix it?
The system monitors the routing behavior, identifies nodes that are suspiciously claiming to be the fastest route, and isolates them before they can blind the city.
Sinkholes are terrifying, but the paper by Sobrino et al. Literally sounds like a sci-fi thriller. They conducted a massive review of 389 articles researching the security of 5G networks against quantum computers.
Are we already having to defend our cities against quantum hacking?
We are in the preparatory phase of what cybersecurity experts call Q-Day.
Q-Day. That sounds like a doomsday movie.
It's the day a quantum computer becomes powerful enough to break current encryption. 5G is the central nervous system of the modern smart city. It allows massive, heavy streams of data to move without wires.
Right.
But the encryption that currently protects all of our 5G data is based on complex mathematical factoring problems. Problems that would take classical, traditional computers thousands of years to crack.
But quantum computers don't play by classical physics or classical mathematics. Exactly. A sufficiently powerful quantum computer running specific algorithms, like Shor's algorithm, could theoretically shatter current 5G encryption in minutes or hours.
Wow.
Sobrino's research warns that if a malicious actor gains access to quantum capabilities, they could casually intercept, decrypt, and manipulate private data across an entire smart city's IoT platform.
So they could turn the traffic lights green everywhere.
Or shut down the power grid.
Hmm.
The research in this area is a frantic race to develop and implement post-quantum cryptography, new mathematical defenses, before the quantum hardware catches up to the theoretical physics.
That is genuinely going to keep me up at night. Let's pivot to a technology that might actually save lives today rather than threaten them tomorrow. AI for safety. There is a highly cited paper by Kahn et al. Regarding the use of deep convolutional neural networks for early smoke detection.
This is a really clever application of AI.
I have a smoke detector in my house. Why do we need advanced AI for this?
Well, traditional smoke detectors, whether ionization or photoelectric, require smoke particles to physically drift up and enter the chamber of the device.
Right, the smoke has to touch it.
By the time enough smoke reaches a sensor on a high ceiling or in a massive warehouse, the fire is often already well established and spreading. Kahn's team developed a fundamentally different approach using visual cameras placed throughout an IoT environment.
So the camera is the smoke detector.
They trained a deep convolutional neural network, a highly advanced form of computer vision, to visually recognize the specific dynamic patterns, colors, and physical movements of smoke in real-time video feeds.
So the camera literally sees the fire starting before the particulate matter ever reaches a physical sensor.
And this ties beautifully back to our discussion on fog computing. Because they deployed this AI using a fog architecture, the video feed doesn't have to be sent to a distant cloud server to be analyzed.
The processing happens on the edge.
Yes. The deep learning AI lives right there in the camera, or on a street corner mini server. It can visually detect a fire and alert emergency services instantly, even in highly complicated environments where visibility is poor, like actual meteorological fog.
That is incredible. And finally, I want to look at the most unglamorous but arguably most foundational dimension of a functioning city. Solid waste. Trash. The Pardini et al. Paper focuses on optimizing waste management. How do you make a garbage truck smart?
This circles us right back to the socio-technical theory we opened the show with. The purely technical solution is to put an ultrasonic fill-level sensor inside every public trash can.
Okay, so the can knows when it's full.
Right. The sensor pings the control center and tells the garbage trucks exactly which bins are full and which are empty. The routing algorithm then generates a custom path for the truck every morning, bypassing the empty bins. That saves massive amounts of diesel fuel, reduces traffic congestion, and cuts emissions.
But if it's just sensors in trucks, it ignores the social layer.
Exactly. Pardini's proposed solution goes further. It incorporates active citizen participation into the data loop.
How does the citizen get involved with the trash schedule?
It creates a framework where the citizens themselves are nodes in the network. Through integrated digital platforms or municipal apps, a citizen can instantly report a damaged bin, an overflowing dumpster, instances of illegal dumping, or request special pickups for hazardous materials.
So the algorithm isn't just relying on ultrasonic pings, it is ingesting human observation.
Yes, the citizens become active participants in the optimization of their own environment, rather than just passive residents having their garbage collected.
It engages the social layer to improve the technical layer.
It is the socio-technical ideal in practice.
The sheer volume, complexity, and diversity of these solutions is staggering. We are talking about quantum encryption races, AI computer vision detecting smoke, decentralized blockchain medical records, and digital twins simulating metropolitan traffic flow.
It's a lot to wrap your head around.
It is. And to prove to you, the listener, that we didn't just cherry-pick these amazing examples out of thin air, I want to briefly look at the extreme rigor of how Boniati and France actually compiled this data. Let's look at the methodology.
It is absolutely crucial to understand the how of this study because it validates everything we've discussed. The researchers didn't just hop on a search engine, type in "Smart Cities Brazil," and read the first 50 links.
Obviously not.
They utilized incredibly strict, globally recognized scientific protocols established by researchers Kitchenham, Charters, and Peterson. In the realm of mapping scientific literature, this is the gold standard.
I found the mechanics of this search fascinating. They use something called the PICOC strategy, PICAUC. What does that acronym stand for and why is it necessary?
It's an operational framework used to define the absolute rigid boundaries of a systematic study, ensuring the researchers stay entirely objective.
Okay, break it down for me. What's the P?
P is for population, the target group, which in this case is restricted to Brazilian researchers.
Simple enough?
I is for intervention. The specific approach being investigated, which is the interdisciplinary topic of smart cities and ICT.
Got it. And the first C?
C is for comparison. This isn't always utilized, but it represents an alternative approach or baseline.
Right. O.
O is for outcome. What specific metrics they expect to find. Temporal evolution, collaborative networks, technological scenarios, and publication venues.
And the final C?
C is for context. The overall environment of the research, which is restricted to the domain of computer science and information technology.
By strictly defining those parameters, they were able to build a Boolean search string. For anyone unfamiliar, a Boolean string is essentially a highly specific line of logical code. It uses operators like AND, OR, and NOT.
Right, it's very precise.
It's like giving instructions to an incredibly literal bouncer at a club. You tell the database, only return a paper if it contains the phrase smart city and the word Brazil, but not if it contains the word agriculture. It forces the database to filter out the noise.
Exactly. And they unleashed this logical string on the 5 most prestigious scientific databases in the world: ACM Digital Library, IE eXplore, Web of Science, Science Direct, and Scopus.
And when they ran those searches, that initial massive trawl returned a preliminary hit of 1,916 publications.
Which is a huge mountain of data to sift through.
It's like panning for gold.
Yeah.
You start with a massive roaring river of data, nearly 2,000 buckets of raw mud and silt, and you have to start sifting.
The sifting process is grueling manual labor. First, they automated the removal of duplicate papers across the 5 different databases, which narrowed the pile down to 11,129 unique papers.
Still a lot.
Then began the human element. The researchers conducted 2 intense manual rounds of reading. They personally read the titles and the abstracts of over 1,000 papers to apply their strict exclusion criteria.
And looking at the methodology, those exclusion criteria were ruthless. They threw out secondary or tertiary studies. They only wanted primary research. They threw out book chapters.
They were not messing around.
If a paper was less than 5 pages long, tossed out, because it likely lacked sufficient depth. If it was just an editorial, an opinion piece, or an extended abstract for a conference, tossed. They were only interested in verified, substantial, peer-reviewed original science.
And after panning away all the silt, all the short papers, and all the non-peer-reviewed opinions, they were left with the pure gold. The 702 articles that form the empirical foundation of this entire 12-year mapping study.
Which begs a final question. Once these researchers strike gold, once they develop a sinkhole defense for an IoT network or an AI that can see smoke, where do they display it? Where does this hardened, verified research actually live?
The study identified 298 distinct publication venues where these 702 articles were housed. About 59% were conferences and 41% were journals. If we look at the top tier of journals, the undisputed leader is the journal Sensors, published by the Swiss publisher MDPI.
MDPI is a huge publisher.
Yeah, it counted for 26 of the selected articles. You also see massive international weight from legendary academic publishers like IE, Springer Nature, and Elsevier.
So they were taking their deeply localized Brazilian solutions, fixing traffic in São Paulo or security in Bahia, and broadcasting them on the highest tier, most visible international academic platforms available.
But they're balancing that international reach with domestic community building. While they publish globally for maximum impact, the study specifically highlights purely Brazilian events acting as internal engines for debate.
Like what?
The Brazilian Symposium on Information Systems, or SBSI, is a prime example.
It operates as a national town square for this specific niche.
Exactly. It has established itself as the premier venue for discussing smart cities from an IT perspective strictly within the country. It allows a researcher working on telecom infrastructure at UFRN in the Northeast to share notes, methodologies, and failures with a researcher working on dynamic traffic algorithms at Unicamp in the Southeast.
It keeps the knowledge in-house.
It fosters the internal domestic ecosystem that is vital for national progress.
I want to try and synthesize this incredible 12-year journey we've just walked through. We started in 2014 with a country scrambling, essentially forced by the pressure of the World Cup and the Olympics, to modernize its failing urban infrastructure.
That was the catalyst.
That massive, chaotic forcing function kick-started a wave of exploratory, fast-paced conference research.
And over the course of a decade, we watched that scramble mature. The output shifted into rigorous, peer-reviewed journal science. We saw a massive, diverse country break down its existential urban challenges geographically.
Tackling gridlock in the south, public safety in the Northeast, and fundamental connectivity in the vastness of the Amazon.
We saw Brazilian researchers collaborating with 53 different countries, while simultaneously identifying a critical need to build stronger ties within their own continent to avoid importing mismatched solutions.
We looked at the actual deployment of digital twins, quantum-resistant 5G networks, blockchain medical ledgers, and AI that can literally see smoke. But through it all, through every algorithm, every Boolean search string, and every ultrasonic sensor, the core philosophy of this entire movement remains the socio-technical theory.
The human element.
The absolute, non-negotiable necessity that technology must serve the human being. It cannot just extract our data. It must tangibly improve our lives.
The engineering, the AI, the hardware. That is the easy part, relatively speaking. Transparent governance, ironclad data privacy, and active citizen participation are the true, ongoing challenges of building a smart city.
So as we wrap up, I want you, the listener, to look out your window right now, or the next time you are on your morning commute, really look at your environment. Look at the streetlights. Look at the security cameras on the corner.
Pay attention to the infrastructure.
Think about the phone in your pocket, silently pinging the nearest cell tower, registering your location. The sensors, the cameras, and the invisible data networks mapping your daily movements are already there. They are quietly, continuously turning your physical city into a virtual digital twin. The future of urban living isn't approaching. It has already arrived.
We are quite literally living inside the infrastructure of tomorrow today.
Which leaves us with one final, deeply provocative thought to mull over. We've talked extensively about data privacy, about the warnings from Bria and Morozov regarding the surveillance trap.
Right, the bloatware analogy.
If a highly efficient smart city fundamentally relies on massive continuous data sharing to function perfectly, for your daily commute patterns, to your household power and water usage, to your encrypted medical records living on a decentralized blockchain, who fundamentally owns the copyright to the digital version of your life?
That is the big question.
When your silent, triangulated movements tell the city exactly where to build a new bus route, are you an active, sovereign citizen of the smart city, or are you just its raw material? Leave you to mull that over.